Yes, class. Good evening. Am I audible? Akifa, Fatima, Hanifa, Hiba. Okay. So I think today was the day, no, only which I had announced for the test, Tuesday. Refraction portion. Akifa, did you receive your answer sheets? What happened? You are becoming irregular in classes. Answer sheets did you receive for your half yearlies that you had in school, Akifa? And Fatima, you also. Did you get your score? And other students, I think only one student in this batch has sent the scores. Zain has told me his marks, no? Let me know your scores, class. Then only it will be, because we have to plan the revision classes and accordingly we'll do it. Let me know whatever scores you are having. What about you, Fatima? Did you receive your score? And if your submissions are now over, then please let me know when can you solve your school paper, exam paper that you had. All right, Fatima. Total marks, Fatima, what was the total marks? Okay. So I have your question paper. Your question paper is already with me. Fatima, but you have to practice. See, you have to take out time from all of your submissions, because otherwise, see, when will you submit? At least you have to first solve your paper that was there in the school. Then I'll give you my papers. But assignments are also there, everything is available, but you need to take out time, no? So let me know, are you free with everything that was going in your school? Because last week I told, so you told me that you had some submissions. So if this is the case, Fatima, you have to take out some time, no, for the practice of physics. Rest of the practice that you're doing on your own, that is fine, but at least the question paper part, at least solve that question paper which you had. And that this is not only for Fatima, this is for other students also. Once you receive your answer sheet, you already know your mistakes, you already know which answer is incorrect. So practice your question paper once again until you score full score. Rest of the this revision classes we'll do. See, now we are going to start with wave optics. Wave optics has, I think it takes 3 classes. 3 classes will be taken by wave optics, 3 or 3.5 classes, 4 classes, let's say, along with the test. So let's say 4 classes will be needed, and then rest of the chapters are of one class. So very few classes are left. Then we'll start with revision. So then what you all will do? Understood. So please let me know, Fatima. I wanted specific date. Not this week. Then fine. Look at the calendar. Check up a date when you can submit your answer sheet. Or do one thing, Fatima. Give the test in front of me. That you can do, I think, whenever you are available, any time. Let me know. Only you will be there in the meeting. I'll be there. You can properly solve your paper. You already know your questions. It's just that you just have to solve it without looking the answers and just practice it on your own. And any other student also who wants to do this, give a single test by your own for any chapter, let me know. I'll arrange a test for you. But that initiative has to be taken by you, and let me know whatever you have. And other students, Sara, Zain, Kulsum, Josefa, Hiba, what about your scores of half yearly? How's your performance in school? The feedback over here and all the test scores are different. What about your scores in school? Let me know, all of you. And as you have your question paper, send me your question papers also on WhatsApp. Okay. Anyways, let's start with the second chapter of the unit that we are dealing with, is the optics unit. So ray optics is over. We had completed with telescope, dispersive power, all these phenomena we had done, and ray optics is over. Within optics only, you have wave optics that basically deals with waves. So there are 3 topics in this. One is Heinz principle that we'll do today. Secondly, you have interference, and third, you have diffraction. There are other topics also written in your NCERT that is not a part of your syllabus, and you don't even need to do that. Polarization, Brewster's law, and all those are not. Okay, Sarah, please send me the question paper also. So these were the half yearlies, no? Okay. Fine, Sarah. I think, Sarah, if you practice a little more, no, your score will easily rise up. Because tests also you have been performing by yourself. So here also you are performing well only, the test scores that you have. But as I've told this, I was telling to Fatima also same thing to you. Practice your paper once again. And do send me your paper. And even if you want to give that paper also separately, you can. We will arrange a meeting for you. So only Sarah, Fatima have told me their scores. So others are not telling, so I'm assuming that you have not received your answer sheet. Akifa hasn't. Rest, I have no idea from others. Now, Heinz principles, what happened? So yes, we'll start with Heinz principle. This is a small topic. We'll try to complete it today. Heinz principle we'll do today. One class for diffraction, and we'll start with interference. One class for interference. Now see, Heinz principle, before we start with it, you have to understand the concept of wavefront. What is meant by a wavefront? So wavefront, you can understand, it's basically the vibrations that occur. Let's take the example. If you have still water with you, you have still water over here. Just assume that you're having still water, river, any lake you have. If you throw a stone or a pebble into the water, what is the first thing that you observe? Suppose I have thrown a stone over here. What is the first thing that I should observe? Or what do we observe? Yes, class. Just imagine a situation where you're throwing a pebble. Good, Hamza. Ripples of water are generated. Exactly, Hamza. What is in the still water? You are able to see this. Like this. This is what you are able to observe in that still water. Water was still, but as you throw a stone, ripples generate. What are those ripples? They are nothing, they are just water only, but they are actually the vibrations that occur. Similarly, if you have a source and that source is generating certain, because of the movement of this source, point source, you have diff line source, any type of source, these vibrations are generating. So the accumulation, or you can say continuous location of the particles in one medium, which are vibrating in phase at any instant. Phase means speed over here. Here phase does not mean the phase difference. Here phase means speed. So wavefront means basically it is defined as continuous locus of all particles. These continuous locus, now I'm drawing it dottedly, but if I have all these points and I collect all these points together, so what will happen? I'll be able to see continuous locus of all the points, continuous locus of all these points together of such particles of medium which are vibrating in the phase at any instant. It means these are vibrating with the speed, and the speed is actually the speed of light, which is 3 into 10 to the power 8 meter per second. So this is known as wavefront. So it is defined as a continuous locus of all such particles of the medium which are vibrating in the phase at any instant. This is what is meant by a wavefront. So best example is that you can understand that if you throw a stone in still water, those are basically vibrations that are present, no, because you have thrown a stone. So similarly here, that stone represents any source. Source can be anything. that we are not. It can be a point source, it can be a line source, it can be a plain 2D source, it can be any source. But that vibration, those vibrations that are obtained, those are known as wavefront. Fine. And rays are perpendicular to the wavefront. If I want to draw the, let's say these are the wavefronts, so I want to draw the rays. So I'll draw the ray like this because rays are perpendicular to wavefront. Rays are perpendicular to wavefront. Now, depending upon the type of source, whatever is the type of source, there will be different types of wavefronts. So if I have a point source, for point sources, you obtain a spherical wavefront. These are so for point source, we have spherical wavefronts. Let's say this is the source. Now see if these are the wavefronts that are obtained. These are the wavefronts that are obtained. So how will I draw the ray? Rays will be perpendicular to this. So rays have to be drawn like this. This is how the rays have to be drawn. These are the rays. And this is the wavefront. So spherical wavefront is obtained for point sources. If you have cylindrical wavefront is obtained for line source. If you have line source, for line source. For example, I have this line source. Now tell me how many point sources can you see in this line source? Point source, you know, this is a point source. I am asking how many point sources can you see within a line source? How many points? Infinity. Good, Zen and Josefa. It will be infinity. Infinite point sources will be there here. Here will be 1 point source. Here will be 1 point source. All these will be point source. And every point source will be producing a circular wavefront, spherical wavefront. Similarly, here also spherical wavefront will produce. At every point, like pile of coins, all the spherical wavefronts will get accumulated. And if you join, how will it look like? This will appear like this only. So basically, cylindrical wavefront is what? Cylindrical wavefront is for line source. So now ray diagrams, if you want to draw it perpendicularly, these will be the rays. These will be the rays. So it's like spherical, one point source is there, it has its spherical wavefront. Then a point above it has spherical wavefront. A point above it has continuously it is like a pile of coins. Even if you arrange pile of coins, what will happen? It looks like a cylinder. Same thing. That's how you obtain a cylindrical wavefront. Fine. Now let's say some parallel rays are coming. Some parallel rays are coming. So for very distant objects, you obtain a plane wavefront. So plane wavefront basically means if this is your wavefront that has been obtained, rays will be perpendicular like this. Rays will be perpendicular. This wave optics is not very difficult. It is in comparison to ray optics. This is simpler and easier only. So, and it's not even lengthy. Now the lessons are not lengthy. Ray optics was a bigger lesson that was left. Yes, then you have diverging and converging. See, if you see, no, if you think wave fronts are increasing, like this. Now see, how will you draw the rays perpendicular to it? So what is happening? Rays are getting diverged. So these types of wavefronts are known as diverging wavefronts. Correct. And see, if somehow the wavefronts, these are decreasing. Now what will happen? Even if I draw the wavefronts perpendicular to this, the rays are converging at a point. Rays are, what is happening to the rays? Rays are converging at a point. So when the rays were diverging, divergent wavefront. When the rays were converging, converging wavefront. This is all about the types of wavefront. So 5 types of wavefront. I am repeating the wavefronts that are present. Point source, the wavefronts that you obtain, spherical wavefront. Rays will be perpendicular to it. Collect all the point source, that means form a line. You get cylindrical wavefront. Rays will still be perpendicular. If you have a very distant object and all the points you accumulated, you'll get a plane wavefront. Rays will be still perpendicular to it. If these wavefronts are increasing, so the rays will be diverging, so diverging wavefront. If the rays are decreasing, so the rays will be converging, so converging wavefront. First tell me, till here, do you have any doubts, any queries? Is it clear to you or not till here? Yes, no, what?
Yes, sir.
Planar 1-4 was distant, a very distant object, an object that is kept at a distance more than, let's say, you can take some distant object, as in you can take not exactly infinity, less, more, definitely less than infinity, like celestial objects. Those are not located. You can see no celestial objects. So these are also distantly located. So any object that is distantly located, that will be considered, that will form a plane wavefront, and that plane wavefront will be having rays around it. All right, so do one thing, all of you write it down, but wherever you have doubt, let me know. Though this Heinz principles part is not difficult, I'm telling you, this part, this whole principle is not difficult, and questions usually come from interference and diffraction parts. But you have to prepare this also, because now since very less topics are present. Okay, class. Now starting with means what is Heinz principle? So see, this principle basically says what? You have a source. Let's say this is some source. Now this source will do what? This source will produce a wavelet, wavefront. As we have discussed, any kind of source will produce a wavefront. That means waves are what? Just consider, keep in mind that we are talking about waves. So we will be talking about the terms like disturbances, vibrations. So similarly here also a source S is there. A source S is there. So what will happen? If the source is there, it will produce wavefront. So here also this source will do what? This source will produce a wavefront. Let's say it has produced a wavefront. Fine. So since this is the first wavefront that has been produced, let's say some time interval t is equal to 0, this wavefront has been produced. This is known as a primary wavefront. By primary wavefront, because this is the first wavefront that has been formed by the source. Now see, as these Josefa and someone answered, no, Josefa and Zen, they answered that a single line source has infinite point sources. So here what will happen? Do you think this wavefront will be having no point? Definitely not. This wavefront that I have drawn right now, this wavefront, it will be having all the particles on it, right? Do you agree with this fact? Source produced a primary wavefront. Primary wavefront has point sources on itself. So now all these point sources, let's say this is one point source. This is, I'm drawing it separately so that you can easily see. Otherwise, these are closely located. This is one point source that is present. This is point source. This is one point source. This is one point source. This is one point source. Like this, point sources will be there on the primary wavefront. So what will happen? These primary wavefronts, these point sources on the primary wavefront, they will become now the new sources. These point that are present, the points that are present on the primary wavefront, these become the source, fresh sources. These become the new sources now. Now this will produce another wavefront. This will produce another wavefront. This will produce one more wavefront. This will produce one more wavefront, and so on. Now what is happening? This is formed, this wavefront that is formed, this is known as secondary wavefront. This is known as secondary wavefront. These wavefronts have been formed by, these wavefronts have been formed actually from the primary wavefront, but these are actually because of the new point sources. No, all these sources that were present on the point, on this primary wavefront, what will happen? These are acting as fresh sources of the new disturbance. So new disturbance has been created. Let's say this is secondary wavefront. Now, what is Heinz principle here? This I have told you. Heinz principle basically tells about the forward propagation of the wave. How a wavefront propagates forward. How does a wavefront moves? The wavefront will move. How will the wavefront move? So see, what is the mechanism behind? This till here you have understood. Now see, if I join all the forward envelopes, see here, this is the wavefront that has been the wavefront has propagated forward. Now this is, let's say this is happening at t is equal to t. Let me draw it again. So this is formed at t is equal to 0. All right. Now what will happen? Now all the point sources that are present here, these will become the new sources. Then again the new wavefront will form. Like this, it will keep on moving forward. This is what is meant by Huygens principle. I am repeating it. I am repeating this. Listen it carefully. Each point on a wavefront, see, a source is there, source produced a primary wavefront. Now each point on the wavefront acts as a fresh source of new disturbance, called the secondary wave or the secondary wavelet. These secondary wavefronts, secondary waves, say secondary wavelets, say these have been formed by these primary sources. Fine. From the primary wavefront, you have obtained secondary wavefront. The secondary wavelets spread out in all direction with the speed of light in the medium. Means the speed with which they propagate is the speed of light, 3 into 10 to the power 8 meter per second. So even if you want to know this distance will be what? Speed is this, time is this. So distance that will be covered, or radius you can say, will be c into t. Not t is equal to 0. This is some t is equal to t. Okay, so these propagate with the speed of light. The new wavefront at any later time, is given by the forward envelope. This forward envelope. If you join all the secondary wavefronts, that give you the new wavefronts, which is tangential surface in forward direction. This is how you draw. You drop a tangent on the secondary wavefronts of the secondary wavelets at that time. This way, this has moved further. Now again, one more will come. This like this wavefront will keep on propagating in the medium. This has now come here. This will now come here. This will now come, and so on. This will keep on moving. This is simply Huygens principle. Any doubts? Then we'll do a question on this. This is just totally theoretical. Huygens principle is totally theoretical. Did you understand or not? Any doubts? Understood? Akifa? Clear? Fatima? Hanifa? Hiba? What about you? Hamza, did you understand? Fatima. And what about you all? Kulsum, Sara, Zain, Huzefa? Here? Clear? Just write it down. Any doubts you have, let me know. Now see, one question is there. If prism, convex lens, concave lens, all these are present, that if a plane wavefront is there, then how will the plane wavefront pass through from here? So let's take the first case, that is prism. So if a prism is there and a plane wavefront is there, see, any of these can come in your exam, and apart from this, none other question can come in your exam. Only these 5 are important for you. Please pay attention to this, how to draw the wavefront, and plane wavefront is given. So let's say this is a prism that is given. You have a plane wavefront. So let's take randomly 3 points I have taken. This is A point, this is B point, this is C point. Random 3 points. You know there are so many points, there are infinite point sources. I'm not referring to all of these. 3 random I have taken. What will happen? Rays, incident, this is the incident wavefront, right? Plane wavefront. So this is what? This is the incident wavefront. This is prism. What will happen? Firstly, rays will pass through this. Rays will pass through this. Now what will happen? Prism is there. You know this is a different medium. A phenomena that occurs whenever a medium is changed. What is that phenomena? Refraction. Good, Father. So here also light rays will get refracted. Here also light rays will get refracted. So these are rays. If these are the rays present, and if we draw the wavefronts for them, one wavefront is this, other will be somewhere here, because this distance is small. Can you see this distance is less? This distance is larger. So the wavefront will also be formed at a larger distance. Here the distance is small, so wavefront will be formed closer. How do we write it? We join the forward envelope by this. So if you drop and join the forward envelope, you get the final wavefront like this. This is how the case of prism is dealt. Fine. Secondly, I think you have convex lens or concave lens. Convex lens. So for convex lens, remember it as it is. What I'm telling. Plane wavefront. Any doubts you have in between, you can interrupt or text me on the chat column. I'll respond. But in between, do that, because otherwise it will become difficult. Now you will copy only, when I'll ask you to write. And I have taken a convex lens. Now what will happen? Same. 3 points I have chosen. A, B, C. This is at a greater distance. This has a higher distance to travel. This is narrower, so this has a smaller distance to travel. This has A and C have smaller distances to travel. B has to go into a larger depth. So what will happen? Now this does work what? It basically converges. Convex lens does what? Convex lens converges. So one ray here, one ray will be here. Now talking about the wavefronts. The wavefront for this will be formed a little closer. For B, it will be formed at a little distance, and for this, it will be formed here. For B, we can say it will be formed closer. Right? This is how it has to be done. Larger distance, smaller distance here, closer. Join it. This is what? This is basically a converging wavefront that has been obtained, or this shape has been obtained. So this is how a convex lens is treated. So converging lens, converging wavefront you have. Let's talk about concave lens. If you have a concave lens, 3 points. Now opposite will occur. See A, B, C. These distances from A point is lesser. So it will be, the wavefront will be formed closer. This wavefront will be formed closer. Now, and B has to cover a larger distance. So it will be formed at a depth. C is formed closer. It will be, this will form closer. Now, if you join all the forward envelope, you get this shape. And rays will always be perpendicular. Here it will be diverged. It will be diverged. Correct? So see, for concave lens, you're obtaining a, this is what type? Here you have drawn, from here the rays are going. Diverging wavefront you'll obtain for concave lens, definitely. Now mirrors, yes, if mirrors are, these were the cases of lens. If you have a mirror, instead of it, you have a mirror. Let's take convex mirror you have and concave mirror you have. Firstly, let's talk about convex mirror. This is convex mirror. Same thing. For convex mirror, if 3 points are chosen, A, B, C, ray of light, this gets reflected, right? Ray of lights, let's say, this will get reflected, because in mirror you already know refraction does not occur, reflection will occur. This has to cover a larger distance, A point, so it will be formed here. B has to form a, this has to cover a smaller distance. Now this will be formed here, let's say, and even without going it, by looking at the figure, if you join, you get a C shape back like this. This is not visible. Just make sure this is clear. Same thing if we talk about concave mirror. This was a convex mirror, concave mirror. So again, 3 points, any points you choose, no need to take only 3 points. This time concave mirror will converge the rays. It will converge the rays. What will happen? Here, see this A point, this has to cover a larger distance. Here, let's say this is formed. This has to cover a more larger distance. This will be at a farther distance from this. This will be formed a little closer. If you join, you get a shape like this. All right, this is how all the rays, you can write A, B, C also. So for concave mirror, concave lens, convex lens, and prism, these 5 cases you have to do. So remember it like ray diagrams only, step by step, write it, step by step, remember it. And directly like this only question will come, especially prism one is important. This one, this is the most important among all. Prism and convex lens. Convex lens also mainly prism. Prism is very important. All right, note it down. Any difficulty you have, let me know. Whichever object, I'll repeat it. Done, class? So I'm writing down the questions. Uh, you'll start. You have 5 minutes though, but that till that time I'm writing down the questions. You can start the paper along, or you can wait also. Okay, Akifa, you can leave. Thank you so much. Hanifa, you also can leave. I've received yours. Okay, Josefa, you can also leave. Others also submit. Hurry up now. Fatima, yours I have also received. You can also leave.